Hello, I'm going to show you how to capture a family of curves that show changes in performance with varying load. First of all, let's set up the frequency response analyzer control panel. We'll go for 100 Hz to 100 kHz frequency range. We'll use a standardized signal generator output of 20 milliamps. No offset, 20 steps per decade. We'll sweep auto. We'll use a log frequency axis. We'll interpolate the plot. We want narrow band because we're just looking at each frequency individually. And we want auto set up for the first one. We're going to go gain phase. Now we turn the power supply on. It's a 5 volt TI power supply with a 2.5 amp load. And now we'll start the sweep. It's found the correct amplitude range. It's characterizing the gain constant, and now it's plotting the gain phase plot from 100 Hz to 100 kHz. It's got a very linear response for the gain. We used 100 Hz bandwidth to minimize noise. You'll notice that it auto-sized the spectrum display gain and phase axes. Now we'll turn on the markers for showing gain and phase. We can see that the phase margin is 60.7 degrees at a frequency of 8,460 Hz, and the gain margin is minus 10.16 dB at 26.6 kHz. Let's add these as reference curves. Right, we've changed the load so it's just over an amp. Let's start another sweep. Again, we find the K factor and then start plotting gain and phase. The gain is slightly higher at low frequencies with the lower current. So we see the plots coming closer to each other as frequency increases. Okay, that's done. Let's add that as a reference as well. Notice that the phase margin was up from 60 degrees to 62.9 degrees. Now we'll start another sweep with a much reduced load current of 0.5 amps. You might notice up here we are outputting the signal generator amplitude. This is a useful bit of information. Right, and now the phase margin has changed to 65 degrees. We can review the earlier curves by using the curve select control here. As we step through the control, it shows each curve in turn. So there's the very first one we captured. Let's go and look at the phase for it, and we can probe all over the curve and then switch to the next one, which is that one, and then the next one again. So you can see that we can capture a family of curves and then probe and check the values for each curves. As you'll see, the gain and phase margin are being updated as we change through the curves. Finally, we can use annotations to label the curves. So we click the annotation tool and go over here, for example, and write 0.5 amps, and down here 2 amps, and here 1 amp. We can move the annotations around after the fact like this, so we can actually put the thing on the curve, and this one here on that one, and this one on that one, or maybe we can find some better place for it, like here, and I don't know, here. So anyway, you can see that we can label it, and we can copy and paste this into a report, and we can save it to disk for future use. We hope that you find this facility in CleverScope useful. Thanks for watching.